Okay, then I guess we'll get started here. So once again, I want to thank you for spending some time with me this afternoon to watch one of our presentations on Allan Block University. And today we're covering just the basic installation of our segmental walls. And I've added a few more things in than just the basics to make it a little more informative for you. And but we'll get started here. And again, thank you. If you have any questions, there's a chat box at the bottom. If you could type your questions in below, and I will periodically take a glance down there and see if there's any questions that I can answer going through. So go ahead and type them in anytime you have the question, and we'll get to them eventually throughout the course of the presentation. So, okay, once again, thanks a lot for being here today. And the objective of this presentation for you guys is, basic engineering, right? Basic installation, the base installation, how to stack the blocks appropriately, soil compaction. What is wall rock? We talk about wall rock all the time. Water management. What's the things you need to do to make sure that your walls, after you build them, are going to stay up forever and ever? And capping options, terraces, surcharge, and I'm sure much more. So the place where you're going to get this information anytime you want is on our website, theallanblock.com. And in particular, if you're looking at walls that are 6 feet or under, go with the left-hand version. It's the Landscape Walls Guide. It is dedicated to those walls 6 feet and under. The blue one is the commercial install manual. This is anything taller than that, including down below the 6 foot, because obviously some commercial projects have short walls as well. But in those two books, you're going to find a wealth of information, and it's going to talk to you about anything and everything we talk about today, and then some. So those two books are something I really encourage you to do. They're both available on allanblock.com. Very easy to find under the catalogs tab. Okay, so I'm going to start off by telling you that if you're not already certified, you should get certified. So Allan Block has a certification program, and we've had it for almost 25 years. And we have 3 levels. You start off with certified, you move into experienced, and you eventually can get to master wall builder, depending upon how large projects you do. You can step through these certification levels fairly quickly, or some smaller guys maybe takes a long time. But the reason you want to get certified is the National Concrete Masonry Association, the industry partnership with the NCMA, they are requesting to engineers that are designing projects that they specify a certain level of experience for their installers on some walls. So the more experience you get, the better your resume looks. And on allanblock.com, once you become a certified installer, you send us information on the walls you continue to build. That's going to increase your resume. And you can go on to allanblock.com and actually print out a resume. It's going to talk about your company. It's going to give you all of the projects that you've submitted. And it's a very nice little, very impressive little piece of information you can then take on and present to your clients as a way to, boast about your experience. So take advantage of that. So again, level 1, basically you have to go to a class, and no matter where you are, there should be an Allan Block producer somewhere nearby, and we run contractor certifications at our producer partners very regularly throughout the year. So you can find that information on the website as well, on dates and times. Experienced is simply build more walls, get some engineering behind them, bigger walls, and the more you grow, the higher your experience level, all the way up to master wall builder. So here's a few landscape walls just to show you how nice some of them can look. And again, I don't know your guys' experience, whether you've built some Allan Block walls before or this is brand new to you, but I hope at whatever level you are, you're going to get some good information today. This is a standard Allan Block unit. It's got a raised front lip, a notch at the bottom. It's got wings on the side. The wings really are great for handholds. They allow you to pick up the block and move it around very easily. The hollow core allows you to put wall rock in the cores, which then transfers down between the courses, and when it's consolidated and compacted, it helps to add in the shear strength and the connection between courses. So the wall rock is not drain rock. In the early days, a lot of people would have thought about it as drain rock, but it's really wall rock because it does much more things than carry water. Its primary function is to aid in the compaction in and around the cores and behind the block. So the top lip provides shear strength, as well as the interface between the two blocks sitting on top of each other. The concrete to concrete interface has shear strength, and then the rock in the cores provides that. So those three things add together to make the Allan block unit have probably the leading amount of shear in the entire industry between courses. And again, it helps keep the courses nice and tight together. The other thing the leading lip does and the lower notch, they combine together to build in the setback of the block. So on the left-hand side, we got the AB stones at 12 degree and the AB vertical at 3 degree. The AB classic is 6 degree, so to find itself in the middle. The hollow core system, again, is a really terrific thing. It's great for you guys moving the block around because it's lighter. It allows you to have very good handholds. You can have superior drainage in or around the block because it has a secondary area for the water to go through it. It dries faster because it has less concrete area to absorb the water. There's better freeze-thaw resistance because, again, it stays drier. Same thing, efflorescence is less because it's drier. The faster labor rates, the lower labor, faster installation, lower production and labor freight costs are because the block is lighter. You can have more block on a truck than you can other blocks that are solid because they don't weigh as much. And when you put the core, fill the core with the wall rock during construction, it weighs exactly the same as a solid block. So it's a perfect way to build your wall with the rock. So here's an example of how the wall rock lets water run through. If any incidental water gets into the wall rock, it's going to run down and eventually out the drain pipe. And again, we're promoting the idea that incidental water, this is not meant to be a drainage column. You don't want to put all your water running down this front. It's not what it's meant for. So again, this illustrates the drain pipe at the lowest part of the wall. So in this illustration, it's below grade. So that means that that pipe needs to exit to some other drainage system below the grade. If it's above the grade that you've got to exit the daylight, I'm going to show you a detail coming up. So here's a slope at the bottom of a wall. So your drain pipe will be as low as possible in the wall, and then as water comes down through the drain column or the cores, it'll eventually get into the pipe and it can route under the wall and be directed out down the slope. If you need to capture the water and actually exit it to daylight, this is the most common detail you should be using. You should have what we call the alternate drain detail. So if you are exiting to the front, the water is going to come down and hit that shelf, and the water is going to get into the pipe and out the face of the wall. Again, handholds for easy maneuverability, and again, the idea that truckloads, we can put a lot more block on a truck than you can like a solid block. One of the big blocks, the wet cast blocks, you can only send a few of those out on every truck because of how much they weigh, and you can send hundreds and hundreds of Allan block out on a single truck. And we all know that truck trips aren't exactly an inexpensive proposition. So here's an example of our vertical, our 6 degree and our 12 degree setbacks. And again, they're built in to the block with the lip and notch combination. So here's a standard cross-section of about an 8-foot high wall. We've got 60% grid lengths, meaning 60% of the height of the wall is, generally speaking, the depth of our standard grids. Depending upon what's above the wall, whether it be a slope or a surcharge of some kind, you may see the engineer increase that top layer of grid by, roughly 3 feet is pretty common. Sometimes if the wall's even taller, you get 2, maybe 3 courses at the top lengthened. It's a very common detail, and as you're building it, this is what most of your walls will be looking like for sure. Okay, so geogrid. Geogrid basically comes in 2 types. Uniaxial, meaning it's strong in one direction, or biaxial, meaning it's the same strength in both directions. In this illustration, the machine direction or the roll direction is the strong direction. So you need to put that grid in perpendicular to the wall face. If you put it in incorrectly and you rotate it around and you roll that along the wall and you're using a uniaxial grid, you could have grid strength in the direction of the force about half as strong as the strong one. So you really need to know what kind of grid you're using and how to put it in correctly. So the rock lock, that wall rock, it will come down through the cores and it'll grab onto the grid and make it a virtually continuous connection from end to end of your wall. Here's a little illustration. When it's consolidated and you pull, it grabs on it entirely, and like I said, virtually continuous connection from one end to the other. So again, water management. We've talked about these 2 details earlier on, but the drain pipe that's going to come through the face of the wall. Some contractors like to put it right in the middle of a block. You have to cut the back and the middle front. Some contractors will cut it along the edge. So they'll cut a square out of the end of the block and then the adjoining block to form that for a round tube with a square rodent screen. But there is a new product on the market called Wall Drain Pro. Wall Drain Pro is really a slick product. We are promoting it. We don't own it, but we think it's a great product enough to promote it. You just simply slide your block apart and it fits vertically between the joints. It's really very easy to use, and we're seeing it used all over the place. And you get it at any of our producers will carry it. Radiuses. Radiuses for the large block, for the full-size Allan block, the tightest radius is about 4 feet. When you think about the bottom course, though, you need to increase the radius of the bottom so as you build your wall and you have the setback that you don't get less than 3 feet, or 4 feet, excuse me, at the top of the wall. So I encourage you to take a look at those manuals. There's radius charts in both of them, and give yourself a little room. If you are trying to hit a 4-foot radius, I tell you what, it's a tight radius. So give yourself a little room. Maybe try for a 6-foot radius. The homeowners and the commercial wall installers always try to give themselves a little more room, and the homeowners are going to be hard pressed to know the difference, because they're going to look for a much high quality wall, and you want to have a little more slack in your radius when you're building, just to make it easier on yourself. And to facilitate those curves, we knock the wings off. Very simply, you can knock them off just like this. Face the block down, hit the wings downward, and it breaks off really nicely. And then you can fan those webs together. On an inside radius, they're fanning apart. No need to take them off. So compaction. Compaction is very important. Compaction, if you just pour the rock out of your Bobcat bucket and walk away, it's not consolidated at all. If you run a plate compactor over rock, you're going to consolidate it. The same with soil. If you don't compact your soil, eventually over time it will self-compact. And if you allow it to self-compact, you'll have settlements above your wall, and you don't want to be called back a year after you've built the wall and having the soil sagging behind because it's ponding, because that's a clear indication that you didn't compact your soil. So compaction is very important to any wall. The vibratory plate compactors is what we recommend, because that's allowed to be in the front part of the wall. You can run it on top of the block and right behind the wall, and you're not going to damage or force the wall to roll over a little bit. If you use a jumping jack, like this ramming machine, it's potentially going to dislodge your facing, and you can use this beyond 3 feet, but not within 3 feet, and I'll show you a slide here coming up. So typical construction, you're going to put a 6-inch deep by 2-foot wide bench, trench underneath your wall, and fill it with rock. In this case, we've got some illustrations to show that you don't just start compacting on top of the rock. You need to also compact the bottom of the trench to make sure you're compacting any loose material, and then start placing the rock in the trench, compact it. Get it pretty level, okay? Start taking care with your level right from the beginning. So when you're compacting and you're running a plate compactor, you're not looking for it to be perfectly level, because you're going to come in and fine tune it a little bit by hand as you're placing the block. But compact it well, and then fine tune the levelness under each block as you're building. So here's a wall that's getting ready to be built. They've obviously overdug the trench, and they've filled it with rock and the pipes down there. So they've got some work to do, but the guys are starting to compact here. And we've started laying it out. We've got a string line here in this illustration, but I want to make it very clear. You need to level each block. Level it from side to side and from front to back. So front to back means from the back of the block to right behind the lip. I have, over the last 17 years of working with Allan Block, I have occasionally got a phone call where a contractor has leveled it by putting his level on top of the lip and to the back of the block. That is not the right way to do it. You will have problems. So you're leveling it based on the flat part of the block, and from side to side and front to back. When you're compacting, you're always compacting from the wall back towards the cut, because you're moving away from the wall. You're putting tension in the grid when you're compacting on soil above grid layers. You're adding consolidation to the material in the cores of the block when you run it on top of the block and behind the wall. But don't run it towards the wall, because that has a tendency to possibly dislodge the wall or roll the block forward slightly. So here's an illustration of some building a wall. We'll take a look at. If only it was this easy and fast. Drain pipe is in place. Material is placed. The only thing this video neglects to do is the compacting of the base of the trench, and I always want to point that out. So we're leveling from front to back and from side to side, and we've got our block lined up against our string line. String lines are really great for straight sections. You might use a garden hose to lay out your curved areas. A very common way to do that. That can be, you can put some spray paint down on the grass before you start digging, so you know the position. And we're going to, again, compact from the wall backwards. So after you place every course, and I mean every course, you should double check your level, because if you do need to make some corrections, it's very easy to do at a course by course basis. If you do it after every third or fourth or fifth course, then maybe it's out of level and it's a lot harder to get back in level. So every course. So here's an example of the next course. So after we've placed the first course and we're going to place the second course, we want to make sure it's all cleaned off so the pebbles don't cause any problems. And notice when the blocks go on, they slide them to the side. They place them and slide them, place them and slide them. A little bit of slide actually takes the slag off of the top of the block, if there is any, and it makes the top of the block a little smoother. So we encourage you to drop it and slide it, drop it and slide it. So we're placing the aggregate in the cores, the infill soil, and we're compacting on top of the block towards the cut. And again, we're going to sweep it off and get ready for now the third course. And again, all of this stuff is covered in the Landscape Walls Guide or the Commercial Installation Manual. Reinforcement charts. So this particular reinforcement comes out of the residential walls. It's walls up to 3 feet tall. Various surcharges. No surcharge. Lightweight commercial residential driveway, or a 3-to-1 slope above. Based on your wall height, your soil type, you can determine how many rolls of Allan block grid. This is based on our 3 or 4 foot wide Allan block grids. And these are lightweight geogrids. These are bidirectional, meaning they are the same strength in both directions. So what this means is you can take these and actually roll them out along the wall, because again, they're the same strength in both directions. A uniaxial grid, you cannot do that. You need to put that perpendicular to the wall. So again, landscape walls, they're really defined by walls that are 6 feet and under. Even if you're on a commercial site, a 6-foot wall could be a landscape wall, but oftentimes commercial sites, you're going to have a little heavier surcharge maybe because there's a parking lot. So landscape walls here, we're going to use predetermined 3 and 4 foot grid rolls. The reference charts, like I mentioned, are lengths and numbers. That's all in that green residential walls guide. We're always going to start the grid on top of the first course and every 2 courses after that. We're trying to really simplify the residential walls that you're building. Again, on a commercial grid, you might have your grid come in a large roll. You're going to roll that off. You're going to cut it, and you're going to place it right behind the back of the lip. And again, you'll place block on top of it so that you can pull that grid tight and stake it off, like is shown here. Again, you're going to compact with the plate compactor on top of the block back to that 3 foot area. You certainly can use the plate compactor all the way to the cut, but if you are going to use the heavier roller type things or the jumping jacks, they need to be behind the compaction zone. So here's a quick illustration again of grid positioning. So you're going to pull it off the grid roll, and you're going to lay it right behind the back of the lip. Put the block on top of it, and then that allows you to pull it tight and stake it so that it stays tight while you're placing the rock and compacting, like we've seen. Again, keep track of the level as you're going. But this picture is great because they've run the plate compactor on top of the block, and you can see that the rock inside the cores has actually consolidated down into the cores. And that's going to happen to your wall too. When you run the plate compactor, it's going to vibrate the rock and the block itself, and the rock is going to drop down into the cores. And Kevin, you've asked this question. Did you say grid length is 60% of the wall height? Very typically, if you have a 10-foot high wall, you're going to have 6-foot grids. So 60% of the wall height with either a 3-foot or 4-foot minimum grid length is very common. So yes, 60% is again very common. Not always. Depends on the soil. Depends on the surcharge. Your engineer designing the wall may go with 70%. Again, another common industry number. But yes, that's exactly what I said. 60% of the wall height is generally speaking the length of the grid. So here's the consolidation zone. So this is the area that your plate compactor can be run on the block and behind. Again, all the way to the cut if you want to, no problem. But make sure that anything heavy compacting is in the compaction zone behind that 3 foot. So let's look at some construction tips. For placing the grid on inside curves, the geogrid tends to fan out from each other. So you're not getting 100% coverage. So a very common thing to do is to mark the wall with a piece of chalk where those joints between the grids are. And then on the next course up, you're going to center a small piece of grid in order to get that 100% coverage. And then on the next course up, you're back to the fanning out. The other next course above, you're going to put that piece in. So take that at heart, and your inspectors will like to see that too, for sure. For outside radiuses, the grids tend to overlap. So overlapping grid actually acts more as a slip plane. So we want you to peel up the one layer and put rock in between. And the grid guys tell us that 2, 3 to 4 inches of soil or rock between the layers makes the grids act independently again and not as a slip plane. So that's important to know. When you're placing grid in the inside corner, you'll choose which grid. One grid will go past the corner, and you're going to go take it past 25% of the wall height. So again, if we have a 10-foot high wall, you're going to bring that at least 2.5 feet past the corner. And on the next course up for grid, you're going to take from the other side. So effectively, you're weaving your grid in the corners, okay? And feel free to put more in, but make sure that you fully compact this area back there all the way to the cut if you have a corner back there. Because we have to remember, if you don't compact now, it will self-compact over time, and eventually that will lead to sagging soil above the wall. And you don't want that. You want to compact it very well now, so that there's no settlement over time. So outside corners, a little bit different, because remember we've been talking about the strong direction perpendicular to the wall. So on this right-hand side, we've got the grid laid out perpendicular, and we've brought it all the way to the corner. On the next course up, we're going to go the other direction on the left-hand side with our strong grid perpendicular, again, effectively creating a weave in the corner. Okay? Turn-ins. Turn-ins are very popular. So as this third course is placed, it's going to turn in and maybe create a planter bed or something, maybe a stairway or something. But you have to remember that underneath this course of block, you need to compact very well. You're going to put another gravel leveling pad, but below that leveling pad, you need to make sure all of that soil is very well compacted, or you could get settlement in this part of the wall, which would eventually look very bad. So over compact. Stress the idea of this area has to be very, very well compacted. So here's an image of a couple turn-ins. Very nice landscape wall drawn in SketchUp as a sales tool for a project that we had here locally. So here's a illustration of how to install step-ups in your wall. I will tell you that if you're going to have step-ups, and most walls do, it is much easier to start building at the lowest point so that you're stepping up the wall. So as you place your block, you're filling in the hole. If you're trying to come down the grade, I have seen contractors do it out of necessity. It's a lot harder, but it can be done. But building it uphill is much better. So that each course is going to terminate after that block has passed the finished grade at the front of the wall. And then as we're going to turn around here shortly and we're going to start moving backwards, we're going to start stepping up in the other direction. So now maybe the slope above is heading back the other direction, and we're stopping the course there. We want to make sure we're doing our proper compaction, and eventually we're going to show you how to do some step downs. Instead of 8-inch step downs, we're going to do 4-inch step downs, and by adding the light stones block to the wall. That's a very common way to do a 4-inch step down as opposed to an 8-inch step down. So here's a way to end the wall. Very common in many parts of Allan block world. You put a corner block on the end of your step down so that you have a split face facing the step. When you put your block down, your cap down, miter the corner. Miter it with a 45 degrees so it looks really nice. Easy way to do it. Here's the illustration of using the light stones in the center, and then here's your turn-ins. Again, making sure that underneath each one of those turn-ins, you've very well compacted the soil. So here's a nice turn-in wall. It's got the Allan block cap on it. This could have had the Allan block cap left off if the owners had decided to do it that way and let the landscape go right up to the back of the lip, and the lip can work as the edging for the landscaping. So let's switch gears a little bit now and talk about how to do taller walls. So these are a couple of the extra things I mentioned. And double Allan block wall is very popular. So a back-to-back AB Classic wall with the back block upside down can add some height. If you have a project that you have a property line where the wall has to be right next to the property line, you don't have room for grid, this might be an option for you. Or the long anchoring unit from our AB Fieldstone collection, which I'm going to talk about in just a minute. Or maybe you want to use no-fines concrete. So no-fines concrete is literally 3/4-inch rock, cement, and water. You can mix it on site. You can get it from a ready-mix company. But what it does is solidifies behind the block, and it makes your facing that much deeper. And it's perfect for tight construction or these other things I've mentioned here. Or big blocks, the big concrete blocks that are spec'd for a project. Does the exact same thing to have an Allan block face and then a mass of no-fines concrete, and it's a lot cheaper. So here's a common cross-section. We've got no-fines at the bottom of this wall, and again, it solidifies and makes your facing depth instead of 1 foot, however deep you've cast your wall. And it can be done on almost any project to the benefit of the owner as a cost savers. Again, that's in the manuals. No-fines concrete in both manuals. This particular wall on the left-hand side, the right-hand side, they're pouring it right out of a truck, and they'll come back and they'll pour it down in the cores as well. But notice they've removed the wings. That's one thing we very strongly promote, to remove the wings of the block to allow that wet concrete to go into that triangular shape between the units. And then when it solidifies, it really does a nice thing to tie the block together with the no-fines concrete. The gentleman back here is shoveling the no-fines into the web areas and cleaning off the block. Most common way to move it around is put it in a bobcat bucket and drop it behind the wall and move it around with a shovel. No plate compactor needed because there is no compaction needed because eventually it will be solid. But one of the most important things to know with no-fines is you have to sweep off the top of the block to make sure that you're not going to leave any of those pebbles to get solidified on top, so it'll really disrupt your next course that's going in. When you're doing an inside corner, this is the only time we recommend the removal of the top lip. So you want to saw cut down in through this lip where the block goes behind, and then you can chisel off the block, the lip that remains, or you can saw cut it. But if you chisel off and you damage the face, it's not a problem because it's buried. But saw cut this part here. So here's an example of the first and second courses. So as they zigzag back and forth, you're removing the alternate lip. Outside corners are very easy because all of our producers make an external corner block. They come in a right hand and a left hand. They're sold in pairs, so that's how you build them. So very briefly on Fieldstone. Fieldstone is a two-part system. You got an anchoring unit and a face unit. The anchoring unit comes in a short and a long. The short is makes the product exactly the same depth as an AB Classic. The long makes it basically twice the depth of a Classic, so almost 2 feet. Some of the pictures, we've got Colonial Series and Sierra. We got Cascade out there, but I want to emphasize the idea that even though it's a two-part system, it's exactly the same installation process as our other blocks. You're going to level the face. The face is leveled very easily because they're smaller. And then you're just going to come in and put the anchoring unit, one anchoring unit per face unit. Face units come in 12-inch long or 24-inch long. If they're 24-inch, you're just using 2 anchoring units. Again, you're compacting on the block back towards the cut. You're cleaning it off to get ready for the next course. You're putting grid in exactly the same way, perpendicular to the face. And you're pinching the grid down, you're pulling the grid tight, compacting. You can glue the caps on if you choose to. It's really up to the owner of the project if they want them glued on. And so let's take a quick look at the outside corner. An outside corner, every 4th block that's made has a finished end that can be used as a corner. So you can have the anchoring unit go between the last block, the corner block, and the next block to hold the block together. And then you were going to put a single unit in so you get back on running bond. Because typically we want to have the anchoring unit with 1 face unit, or 2 for the long face units. I'm not going to go through all the numbers here, but know that the short anchoring unit is, again, roughly the same gravity wall heights as a Navy Classic, and the 2 foot deep can go upwards of 9 feet in perfect soil. Emphasize the perfect soil, flat, no surcharge. But if you need to get taller walls, a long anchoring unit option is available to you. The other thing you can do is parapets. Because the face units are separate, you can use these dog bone anchors to attach the facing together, or you can fan them apart, and then you can cap them with any variety of different things that you have available to you. You can also make posts with it. Or parapets, how about railings, fences above. If you're new to the industry, if you're new to building walls, ask your clients if ahead of time if they want to have a fence above. You build a 6-foot high wall, chances are there's going to be a fence above, and you need to incorporate that into the design. The Sleeve It by StrataGrid is a great product. It's all engineered and it can handle a certain amount of force. It's not the answer to every overturning question, but it does a lot of residential applications or commercial when it's handrails. Or the old tried and true method of simply putting a construction tube in. So the construction tube, you can go deeper, but you want to install it during the wall installation. That would mean coordinating the fence post positions with the wall installers so that you get the right spacing on the posts. Otherwise, at the end, you're trying to auger through it or hand dig it. It's always recommended by us to hand dig if you have to cut through geogrid, because an auger might snag the grid and pull it. And you certainly can't auger if you're using no fine, so you really have to plan ahead for that. So that's it, and I went just a little long, but I felt that the no fine section and the Sleeve It section was really important to talk about today. So I'm going to open it up to questions. So Kevin, you've asked, should an astrotype fabric be placed in the bottom of the trench? Not necessarily. If your engineer has said that your soils that you're trying to build upon are soft, then they might recommend some sort of filter fabric embankment protection fabric, some sort of textile to help when you place the rock and you compact, that rock doesn't just get squished into the clay. So it would definitely depend on the project. But good question. So anyone else? Okay, well, if there are no others, I want to leave you with two thoughts. Please reach out to us if you have any questions. We are here to help, myself, and I've got 5 other engineers here in the office. And the local producers, they're great resources for you. They are the boots on the ground. They are out there doing it every day. And those contractor certification classes, please look into one if you're not certified, and get yourself in the Allan Block family and start using those resumes and taking advantage of our certification program, because we do them for you guys to help you guys be the best you can be. Thanks a lot, and have a great rest of the day, and look forward to hearing from you.